All right, friends, welcome to week 4, lecture 1. It is our last week, guys. We made it. You did it. You're almost there. You are almost there. Just want to say you guys did so well on the belt exam. So way to go. I see all your hard work, and I really enjoyed sort of seeing that come to fruition. I know that this has been a really hard, probably stretch moment for you. And if this wasn't, then great. I'm glad you're brilliant and you already knew this stuff. And if it was, just know that that was very normal. But as a human, that's some of the best things that you can do is sort of stretch yourself and grow there. So just want to say I'm super proud of all of you guys. We're not done yet. So there's, don't totally just give up. There's still a couple things we got to do. But did just want to say super well done, all of you, just so far, throughout the entire 4 weeks. Today is going to be a much more relaxed day. This is probably going to be the easiest lecture of the entire sort of 4 weeks. I understand you guys are just coming off belt exams. Your brain is probably fried. You have resubmits due this week. So we're not diving in too much with code. We're going to look at some and talk a little bit more theory and understanding what like explanatory visualizations, sort of the purpose of those and things that we can do and things that we can avoid, particularly to make sure that what we are showing and explaining makes sense, right? And the user can understand it quickly. We're also going to talk about the 3 considerations when making an explanatory visualization. And we're at the end, we're going to create an interpretive visualization to answer specific questions. I think I have like 3 or 4 questions. I already have the code written out. So we're just going to walk through that sort of line by line, make sure that you guys fully understand what's going on and talk about the different things, especially the different pieces. If you guys did take, there was some common errors on the belt exam, particularly using a histogram with a categorical value, something that a bar chart would have done that, right? Remember that histograms are a distribution of numerical values. So that was by far the most common error, that if you would have just done the same thing, but with a bar, that would have been perfect. So we're going to talk a little bit about that as well. Before we do, I just want to make sure you guys know the end of stack expectations. Every belt exam that I have is currently graded. So if you haven't checked already, in your feedback document on the bottom, there's a little tab, and that's going to say belt exam 1. So when you click on that, that will be my notes. It is out of 10, remembering whether you get an 8 or a 10, it's a passing. So as long as you get an 8 or above, you passed. If you did get anything wrong, I did put, sort of the things that you could have changed, or again, like, hey, make sure your, histogram is for a distribution of a numerical value. So I did take a point off. I did let you guys know I would do that. So I did do that. So any explanation is on that as well. And sometimes I didn't take off points, but I thought it was just important for you to note and say certain things. So that is there. So those are all done. Everything should be graded. And so if you didn't get a grade and you did submit the exam, please let me know and we can walk through that. If you are requiring a retake, I have already reached out to you. So you should be good to go there. Now, things I want you to really hear, and it's super duper important, is if you haven't taken the exam, please reach out to me and I can get you, and I should have emailed all of you. If you haven't taken it, I will get you that code. Or you should have that code already, but if you don't, please email me. If you have to retake or you have to take the exam for the first time, remember that it is due by 9 a.m. on Friday. It is due. It has to be submitted. It can't start at 8:59, or if you do, then you have 1 minute to do the exam. It is due at 1:59 a.m. or 9 a.m. Sorry, I got a DM. So I'm not sure what happened. Sorry, it's due at 9 a.m. Sorry for the confusion right there. I confused myself. It's due at 9 a.m. on Friday. Your belt exam must be turned into me, whether it's your first time or it is your retake. Just as a reminder, if you don't pass the belt exam, this course does require a retake. That retake will incur a $500 fee. I'll get you set up with Robbie if we do have to get that, and he can lay out all the paperwork there. Another expectation and knowledge of you have to have 90% of your core assignments done. That also means resubmit. So if you do have outstanding resubmits, I'm going through tomorrow, and I will send you an email if there is any sort of pending resubmits, or if there is anything that's preventing you. I'll sort of give you a status update similar to what I did before the belt exam. hey, you have, 2 resubmits from week 2 or something, I'll break that down for you. So if you do have any of that, that is also due by 9 a.m. So get that into me. Please make sure you get that into me. That way I can go through and grade it. If you can get it in before 9 a.m., that actually really helps me, because that way I'm not scrambling by 9 a.m. Or, right at 9 a.m. to grade everything and get you on to Josh. So that is, you have to have 90% of all your core assignments. Now that does mean that if you've technically done everything and you've passed all 9 assignments, you technically don't have to do this next one in order to move forward, right? Project 1, part 4 is a core assignment, but as long as you've done 9 out of 10, you do need to do that. What I will say though, is a core assignment starting whenever you have Josh builds off of that. So it is required in that regard. So make sure that you do it. Any resubmits you have are not necessarily going to hold you back. So if you do it and I grade it, and then I'm saying, hey, fix this, it needs a resubmit, that's not going to hold you back from moving forward. So just please know that as long as you've got 90% all of the core assignments that are all good to go, there's no more outstanding resubmits, you are good to go. And then you still have to have 80% of attendance, meaning that you can only miss 1. So still come to class today, come to class on Thursday, and then you'll be good to go that. So are there any questions about end of stack expectations, any sort of things I can clear up? Sorry about the confusion there for a second. Any questions at all?
Oh, there's one thing that I can add. I would strongly recommend that you get started. You should have access. If you've completed all of your requirements to go to Stack 2, you should have access starting on Friday by the end of day. I highly recommend getting started with week 1 on Saturday. Because
Yes,
like I said, things are coming fast and stuff's going to be on the following Friday. So if you want a weekend to work on it, you want to get started on Saturday.
yes, thank you, Josh. For that expectation is Josh will actually be sending you an email on Friday afternoonish. That's going to let you know, hey, you're in my class, you're good to go. Here's all of our Zoom link. You're going to have your own class calendar, just like we do here. Same sort of thing, but it's going to have Josh and all his specific links. And then with that, you will unlock the class. You'll have access over the weekend. But just remember, only the first week of hours did you have until Sunday. Moving forward for the rest of the program, you have due dates on Friday. So as you guys, I'm sure, are starting to gather, working on the weekends is going to be crucial. If you have that ability, they are still going to do Friday. So even week 1 of your next stack will be due on Friday, just like it is in our class. So make sure that you are jumping ahead of that. But you will have an email from me tomorrow letting you know, hey, you're on track, or hey, here's what I have outstanding. So I'll make sure that there's no sort of blockers or fear. If you ever want to check though, which I really encourage you, go to the feedback document. You have access to that already. So that is your, truth right there. So please, please, please do that. Any other questions? Okay. Before we jump in, I would just love to get a little bit of a feel of how you guys are feeling after the belt exam, out of a 0 out of 5. How are you feeling about the material? How are you feeling about the belt exam? How are you feeling about moving forward? Are you stressed? Are you feeling good? Just how are we doing? Okay, lots of 4s and 5s. Guys, that's awesome. Awesome. I just want to point out that 2 weeks ago when we did this, there was a lot of like 2s and 3s. So the fact that you guys are moving forward, just as a reminder, there's always room to improve, just like David said, but really, really excited for you guys that you, take what you accomplished this stack and use that to fuel you when things get hard in the next stack. Cause they will. And Josh will be the first one to tell you they will get hard. That's just how, again, it's part of the growing thing. So okie doke. Yep. Just as always, you got your week 4 core assignment. It is due Friday. Everything is due Friday. So this week, all resubmits, everything, your belt exam, everything is due by Friday April 15th at 9 a.m. So again, any requested resubmissions are not going to prevent you from moving forward to the next stack, but everything must be submitted. Please do not pass the exam, go to all the classes, and then have 2 outstanding resubmits. And I'm going to have to make you, retake. Like, that's, nobody wants that. It's out of my hands. If you don't do it, it's out of my hands. I can't do anything, and it's $500. So please make sure that you are prepared there. Cool. Yep, just again, reiterating, as you can see, I have multiple slides on this because I really want to reiterate everything is due Friday, 4/15 at 9 a.m. PDT. So if you're like me, to where you can't work until there is a panic-induced deadline, please do that now. Give yourself a deadline of Thursday. I do my best work when it's due very, very soon. Yes, Josh wants you all in your class. So please, please, please. And also, you'd be super bored, especially if you're already past the exam. You got to hear me do everything. You're going to rehear my jokes. I don't really do jokes, but you'd have to rehear them. You get very over me very fast. Okay. All right. So let's move forward. If there is any more questions, feel free to put them in chat. Josh is here, and so is David, and they can help you if there is any sort of nuancy things that you are questioning. All right. So last week in week 3, we talked a lot about exploratory data, right? And exploratory data visualization. So using our data to help us understand what's going on with our data, using histograms to understand the distribution of our numerical values, or using a bar chart to understand the counts of a certain category, how many times it occurs, or different things, grouping by a manufacturer and how many grams of sugar are in that, right? And by using those categorical values, I can visually understand what's going on with my data instead of having to look at dot value counts and go through every single thing. And so that's exploratory, really exploring our data, seeing what correlations are, what the different correlations, if there's any sort of impact from, one column to another. Now, what we do is, after we explore our data, and, similar to what you saw in the belt exam, where, a question was asked for you to do something. What we then do is we want to take our visualizations and we want to make them explanatory, right? So we go and we explore our data, figure out what's going on, figure out the question we're trying to answer, and then we use explanatory visualizations to tell a story, right? To help our user quickly understand. Some of the different visualizations within our belt exam, and this is okay because we haven't gone over it, were actually sort of hard for me to figure out, well, what's going on? What's the point of this? Why are we doing this? Why are we doing a scatter plot on these 2 different columns? What is this telling us? And even some of your interpretations, I kind of came from that too, of like, well, I think this is what's happening. It's like, well, yeah, like, okay, but what is really going on? And so we want to go from that to, okay, I want somebody to look at my visualization and instantly I want them to sort of understand within 5 to 10 seconds. It's usually the rule. I know that's on the slide and I jumped early. Within 5 to 10 seconds, we want to understand what's going on and what sort of story are we telling. So if we've got a presentation graph, and the idea is that you might get a board meeting, a board might come to you, or this would be a great example. I've got a buddy who works and creates wearable technology for, a large company that does warehouses. I'm not going to say the company, but large company that does warehouses, and distributes all over very, very quickly. And I was in the car with him a couple of weeks ago, and we were on a call, and it was a YouTube video call. And he was like, do you want to hear about data? Or is that sort of lame? And I was like, no, absolutely. I want to hear all about your data and, sort of what's going on. And so in this this Zoom call, they had a data analyst or a data scientist who was doing data analyzation, and they were taking the data that they tracked from their users, from the warehouse workers, and they visually represented what was going on. And basically they did an sort of A/B test where they tracked how long or how much data happened when they were wearing it, or when a specific feature was turned on, and then what was happening when the feature was turned off, right? And they were using these visualizations to quickly explain what happened. And I tell you that story is because sometimes we might have a technical background, and I can look at your graph and say like, okay, what's going on in this plot? But there were people from the marketing team on this call. There were people from just the operations on this call, to where even they could look and say, wow, look at that instantly within 5 seconds, because it was actually a great turnaround. It was good for their company, but they're like, wow, look at this. This looks amazing, because they could quickly understand it. And so you might actually have that as your job, to where somebody might say, okay, take all this data and I want you to make visualizations. I want it to where board members can understand this, to where another company's proposal, I can put this in. And if the person making the business decision maybe doesn't have, the most technical background, they can still look at this visualization, understand what your product did for them, and then make a buying decision based off of that. And so you might be creating these presentations and specifically graphs within these presentations. And so there's a couple things that we really, when we're dealing with these, that's the idea behind explanatory visualizations. We want to have here's some different attributes and characteristics of what we want. We'd want to have a clear answer to a well-defined question. So is there a correlation between heat and humidity, or are men or women more likely to buy our product? How have searches for Pokemon changed over the last 10 years? And this real world example of, what was the impact of the wearable feature being turned on versus turned off, right? So we'd want to have this clear question that we can give a clear answer to. It needs to be clear enough to really be able to understand in 5 to 10 seconds. If it takes longer than that, that's where, you can kind of start like, what am I looking at here? What's going on? And it can actually deter a company, right? Because if they don't quite understand what's going on, or, what's happening, they're not going to be as inspired to go and buy your product, or buy or do or make some sort of business decision. And so we want to make it clear enough to understand within 5 to 10 seconds. And it needs to be visually appealing, but not cluttered or distracting. We're going to look at a couple after this, and you're going to see some bad examples. And we're going to talk through, why are these bad? What are some issues there? And we want to use shape, color, words, or markers to draw attention to what's important, right? So we don't want this background, just even in this GDP change over 50 years. You can see we have this hue of Australia and New Zealand. And I'm not doing anything crazy. This isn't a 3D model, right? That I can click. Like, what this very clearly shows is that Australia's GDP has grown significantly from 1952 to 2007. And how actually Australia's GDP looks like it has grown more and at a faster rate than New Zealand's, right? And I can quickly look at this just because the graphs or the bars are different colors. I have this legend here, and not too much is going on. It's very, very visually appealing and easy for me to quickly understand. Cool. A big part of this is, again, knowing your audience, right? So we want to consider, is this audience a technical understanding? Am I dealing with other data scientists for the company, right? That way they might understand a little bit more intense graphs or intense visualizations. Does this have the necessary amount of detail? Are we adding too much detail? Things that don't really play into our question? And is this, does this have plenty of content of interest? Again, if we're trying to deal with, some employee attrition rates, are we just talking about like, something that has nothing to do with that? Or does this actually, help us solve the question that we're trying to ask? The second piece of that, so first off, you got to know your audience, right? You have to understand how technically in depth you want to go. Second thing is you have to know your data. And again, that's where that exploratory data analysis comes in. We want to know our data before we just start creating visualizations, because we don't want to falsely portray any sort of anomaly, or we don't want to falsely portray, a good, we don't want to falsely portray our data and what was happening there, right? So we have to know our data before we, sort of mess up and can cost our company millions of dollars. Meaning we have to know our features, right? What's in them? What are these values representing? We have to know our relationships, or their correlations, what's going on between our features. And importantly, we have to know the type of data, whether it's numeric or categorical, right? Cool. Just as a little reminder, for a data relationship, there's like a correlation. A scatter plot is a great chart for that. Any sort of distribution, this is a numerical distribution, right? We want to use our histograms, our box plots. anything that's geospatial. So if I'm wanting to do something with a map or like COVID cases of over, in the US, I might use something like a map. Any ranking or comparison, I can use a bar chart, and then any sort of trends, I can use a line graph. So we're going to use a couple of those today. And then lastly, we got to know our goal, right? What is the question? What question does the image answer, right? Is this question actually answering something, or sorry, is this image actually answering a question, or is it just an image we threw together? And then lastly, what do you want your audience to get out of your visual, right? If you just sit and show a visualization, but our audience doesn't really understand it, they don't get anything out of it, it's a waste of your turn, your time and theirs as well. Okay. Now, I do want to let you guys sort of be aware of some different resources. So knowing what's possible, here's some example galleries, and particularly Seaborn and Matplotlib. But there is some great ones, so like this Python graph gallery, to where I can see for a distribution, here's the different type of charts I can create. And if I look at one, like a histogram, I can see all this code that will actually walk through this, right? And so this is just a quick tool. I think I showed this to you guys last week. If I didn't, it's here now. It's where you can go and look at all of these different types of histograms and different things you can do where you're playing with the bin. And what's nice is it gives you code. So if you are wondering what's the best way to portray this, this is a really neat tool to sit and say, okay, I want to show the correlation between X and Y. Here's the different types you can do with correlation or ranking or, part of a whole tree map versus like a pie chart for the thing. So this is a really, really cool tool that if you are wanting to continue into data analyzing and going into like a data analyst role, get used to this, because this is a great, great tool to make your data visually very, very aesthetic. And then there's Data Viz Project, which is not as broken down, but it can help you with something like, like a line graph. If you go on that, it helps you understand. And there's some examples for some inspiration for colors or what it visually looks like. So you can do things like that as well. So you can look and like, oh, this looks really, really nice. Here's the source. I like the way they did X, Y, Z. So this is a little bit more for inspiration versus this Python graph gallery is a really neat tool for you to further understand that. Okay. Now, what I want to do as a class, instead of us going into groups, I just want as a class for us to walk through these graphs, and I want you to tell me what's wrong with this or how we can improve this graph. Now, I do ask that you can go off mute if you want. You can go off mute if you want, absolutely, or put something in chat. I just want hopefully a whole bunch of different voices in this, but okay. Out of the gates, what do we see here? What's going on? What's a way that this can improve? What do you guys think about this?
The line is confusing.
Okay, so it's a little bit confusing.
Yeah, like I don't know what it's following. Like, is it following specifically the green or blue or yellow bars, or is it like the average of each, like infrarow mirage overpass thing,
Yeah, exactly. You're like, okay, I think that this is, if I'm looking at it, oops, sorry. I think this is map win statistics. So I'm assuming that these are some maps for maybe a video game. But yeah, exactly. Like, what is CT win? What is T win? What is win times played? What else? Great.
Basically, what does CT win stand for? What does T win percentage stand for? Like, what do the win percentages correlate to? I mean, I can kind of take a guess what game this is. I believe. I mean, if you guys want me to announce it, I can.
Yeah, I mean, sure. I mean, it looks. Yeah, I don't. Oh, Natus Vincier. I don't know. Maybe that's the player.
Yeah. I believe he's a player for Counter-Strike Global Offensive. So this game is definitely a Counter-Strike game.
Okay, Counter-Strike, great. Okay, Giancarlo said not very descriptive with the text. Yeah, exactly. Like what's going on here, Matt? If they would have even said map win statistics or Counter-Strike win statistics, divided by map, that instantly would have just this conversation of what am I looking at would have helped. Devin, great for pointing out there's two different axes here, right? To where, okay, that's a little bit confusing. What is this trying to show? How do I sort of correlate these two together? Absolutely. John said text color doesn't work with the background. Yeah, it's like a little bit harder to read, right? One thing that we have to really keep in mind is color blindness. I am someone who is partly colorblind, and so there are certain colors, and you can get into the accessibility standpoint. You can get real deep into that, but exactly, John, really understanding text colors, right? I think this is a great example that sometimes less is more, right? Keeping your visualization as simple as possible can be really key. Having this times played, this win percentage, all of these different win, CT win, T win, times played, there's just too much going on, right? Keep this simple. What are we trying to accomplish, right? This would be a great one if you guys were to give me this, say, what is the goal, right? What are we trying to do here? Are we trying to show the win percentage per map? Okay, cool, let's do that. Or how win percentage changes with times played would be a great like correlation, right? Is there a correlation with however many times you play, your win percentage goes up, right? So there's tons of things here. Too much is going on, less is more. Great job, guys. All right, next one. What about this guy? Got lawn level, bronze, bevel, slant, upright. What do you guys see here? What are some things that could go wrong? What are some things that don't look good?
This graph looks like it should be backwards.
Yeah, right. Looks sort of inverted.
I have no idea what the costs refer to, like what do the top, what does like dollar amounts mean? Like, I have no idea what it means.
Yeah, exactly. What are these costs doing? Zach, exactly. Why is the cheapest option the biggest bar, right? This cheapest option here is the largest bar. There's no description of the graph. Great job, Miranda. There's no labels. Giancarlo, you're exactly right. What, DeQuay, what is this graph about? I don't know. There's no title. Great job, Jessica. Exactly. And so we're sitting and saying, okay, what is happening here, right? Like this is really a particularly poor graph because just like Zach said, this really misleads the audience. This 599 really is confusing because this bar is the largest one, even though that's the smallest value. Now, typically you want to, it's just kind of a rule of thought is depending on what society you're in, that's how you want to create these, right? Like here in the US, we read left to right. So starting from the right and going to the left is a little bit counterintuitive to how we naturally will read this. So even just showing that kind of makes it even more confusing. Yeah, starting at 500, to 599, not quite sure. Again, what question are they wanting to do? And it sort of is misleading our audience, right? Because it seems like 599 is the largest, but really that's actually the smallest. So we want to make sure we don't mislead our audience. Also, because sometimes when we mislead them, it just leads them into confusion. Okay, what do we got here? What about this guy?
Well, basically, the lowest number is 250, which, I mean, the scale just looks really misleading.
Yeah, exactly. Still no labels. Yep, colors are different to see, no labels.
Different fonts for the last bar.
Yeah, exactly. A different font.
I just wanted to, I think I kind of know why they're doing the different font and different colors.
Yeah.
Because it looks like it could be, they're trying to point out like something for that particular company.
Yeah.
So
absolutely.
To me, it's like, that's the first thing I see. That's what I'll start picking out details for. And if they're only putting it 250 as the lowest, I think for them, there's nothing below 250. And if they include everything under 250, the bar would be much more difficult to read.
Yeah. Well, I think, Bella, that's a great point, right? Here, it seems as if maybe we're creating this visualization for this company. And what this does is it sort of misleads our audience as well, right? To even this blue, I'm instantly looking because it's different than the others. I think you could probably argue that, maybe this is a certain type of gray. These are all grayed out, but I'm with you. I think that this, especially because this is larger, it seems like this is really wanting our eyes to look at how cheap Mycen is compared to the others. But if we actually look at it, starting at 250 is a large no-no, right? We always want to start at 0 because this will mislead our audience. This, by starting at 250, makes this look significantly smaller than all of them, right? Versus if we started at 250, it would still be half of this, right? It's still smaller. But if we started at 0, this would still be half of 999, less than half, right? but by starting at 250, it makes it look significantly smaller. So we want to make sure that we are not just like Josh put in the chat, we're not missing our baseline. So we have to make sure we do start at 0. The only time you might see in like academia, if it doesn't start there, you would see like a bunch of sort of like switchbacks or like crisscrossed all the way to 0 to explore and say, look, there was nothing between this. So I'm going to conduce it or truncate it a little bit, but you will always see at least a 0. So you want to make sure that you do have that baseline as well. Yeah, John Clark, exactly. It does seem like it's just, gearing us towards this to maybe sell a product. We don't want to do that. Yep, exactly, David. Again, we don't want to mislead our audience. We don't want to break access, and we always start at 0. So always do that. Okay. Next guy, what about this one? What are we thinking? Exactly, Nick. I hear that one. Ugh.
I'm a little confused with this chart because auto loans, the total dollar amount, it in my mind should be a lot shorter than the mortgages.
Yeah.
And so the ratio is really off and it's throwing it off for me.
Yeah. Right. There's like, Zach, yes, like mortgages seems out of place because it goes like from smallest and then increasing, but exactly, Bella, right? Like the ratio 28,000 is not even like close to 3/4 of 176,000, right? Like that's very confusing. Very, very, very confusing. It doesn't seem like there's any sort of ratios here to like 28,000 is about half of student loans, but it's almost all the way to student loans. There is no rhyme or reason for this. What else do you guys see?
The color for the type or the text and the actual bar is also too close, I think.
Yeah, absolutely.
Yeah, the scale is like way off. It's like literally kind of gives us the illusion that mortgages is like slightly more than like the other types of loans, but it's actually a lot more than the other categories.
Yeah.
Also that any type of debt, I mean, either it should be other type of debt, or what does any type of debt mean? Then it would
Exactly.
include all of them.
Yeah, exactly. Right. Yeah. Any type of debt. I'm glad you caught that. Any type of debt. Well, is student loans a type of debt? Yes, but that doesn't make any sense. Like any type of debt. What is going on there? I don't quite understand. Devin said a wordy title. I would actually say, oops. No, man. Oh no, sorry. The title is probably this types of debt. And then you have this sort of subtitle here that is the total owed by the average US household by debt type. I think it's actually a pretty good explanation of what's going on. If we had a better, understanding of what this debt type meant, right? Like, okay, exactly this idea of any type of debt is very confusing because it should be almost like the cumulative debt. But I don't know what, any other type of debt would have been good or, other debt, something like that. Yep. The text does not look great. Perfect. Great job, guys. You guys are catching on. Again, we don't want to make sure we mislead our audience. Keep sizes proportional to their values, right? We don't want to make it seem like mortgages. If this was like trying to sell a mortgage, this sort of is selling that a mortgage is no big deal, right? Like, oh yeah, like most people, it's not that much debt, but most people have this. When if we were to really put this in, really chart this, mortgage would be way higher than credit cards. So make sure that we keep our proportions, our values. It's actually pretty hard to create that in pandas. Like that would actually be very, very difficult to make it look that poor. Transparently. You'd have to really try to make such a bad one. Okay. This next guy, I think we have 2 more, maybe. This might be the last one. How much do you spend on groceries every week? Josh,
I don't
agreed.
know that.
Go ahead.
I was gonna say, I don't know if I would register that this is a graph at first.
Sure.
Also, like, what's the difference between under 100 and about 100?
Yeah, right.
Like this isn't defined, yeah.
Yeah, like even our scale is under $100. Okay, that's fine. Like 100 or less, about $100. Okay. And then we have $100 to $200, which is like, okay, what does this mean? Should these be together? Is this about, you know, more than 100, less than 100, right? Our scale, it's very, very, very off. What else do you guys see?
I think using the square to represent proportions is extremely misleading, just because, you know, I guess if you think about it, the outer ring pretty much takes up most of the area, so it kind of gives a little bit of the illusion that the ones in the middle are like almost the same proportion as the ones on the outside, where in reality it's, you know, it messes with our minds in terms of thinking about proportions.
Yeah, exactly. It's very hard to sort of understand that this largest 39% is sort of the first area, right? And it's this whole thing is this 30 represents 39%. And then on top of that, we've got this 26%, then 22%, and then we've got 10% and then 3%. It's just very, very confusing. Giancarlo, exactly. Like it takes too long to understand. But yes, also looks like a Canva infograph, right? This would be done on Canva. Absolutely. What else? Anything else, guys?
This is hard to compare between categories.
Yeah, it is very hard, right? Because when we're dealing with these areas, and then all of a sudden I've got this guy, you're like, okay, I mean, I see that this is sort of close, this 22 and 26, but in like relative to this 39, I just don't really understand the distribution of my data here. Yeah, it's very, very, very confusing. And again, I think Miranda had a great point of why is 22 looking larger? Because, right, this whole outside of the green represents the entire area, right? And so then this yellow represents this, and everything within here is the area of the yellow, but because they put it on top of each other, it's very, very, very confusing. Yeah, so it's not the width of the strip, it's actually the size of the square represents the proportion of the 26, the 22, and then the 39 is all of the data.
That's why the square is misleading, because
yes,
strips wider than does the actual area, and then of course you have the like the inner square inside, which kind of represents like proportion, like, you know,
yeah,
just the way that size is just confusing.
Exactly, it's very confusing. Okay, so this is just also a reminder. This looks sort of created, and like somebody said, it looks like it's on Canva, and Canva is an awesome tool for marketing, for creating, you know, marketing tools. But we don't want to we want to make sure we don't use data visualizations to express our creativity, right? We want to keep it simple and we want to keep it clear. Like we want to make sure that we are utilizing, and it's really, really easy to understand, not just like, oh, this looks really, really, you know, looks really cool and hip, but if you can't understand it, you know, we just spent, and it's really, really hard to understand. If you can't understand it, then it's not valid. Okay, last one. What are we thinking here?
There's no labels on any of these colors. I don't know what they are.
Yeah, we have zero idea what the other ones are. And Miranda, yeah, description would be nice.
Why is that piece, like, why is that appliance is like, you know, part like so much bigger as compared to the rest? Are they trying to kind of give the illusion that, like, you know, it's much bigger than what actually is, or much smaller than what it actually is? It's just
yeah, it seems like it's trying to indicate that sort of sand color is appliances, but you're right, because it magnified that, it makes it look a little bit more confusing. Yeah, somebody took a slice of pie, put it back. What are the other pieces? Percentages and labels. Great job, DeQuay. Which is appliances? Who knows? I mean, that's actually a great point, Jessica. Right? We can assume that this is appliances, but it very well could be that this is appliances or this is appliances, right? It doesn't really indicate that this magnified piece is appliances. Great catch. Anything else?
With retrospect to appliances, so, well, assuming appliances takes up 21% of home energy usage, well, by home energy usage, like, you know, how can we quantify the total overall amount of home energy usage? You know, basically, it takes up 21% of our energy, but how much is 21% of our whole
Sure.
energy? Like what kilowatts per hour, what's like, how many kilowatts per hour is it?
Yeah, maybe like the measurement, the type that we used is important and right, could give us some greater understanding.
Yeah.
I'm just gonna say this. It's funny because we all grew up, I feel as if we all grow up learning pie charts, right? And pie charts are like king. But actually in the data analyzing world, pie charts are trash and you typically don't do them. Everybody loves them. But the reason is because from a circle, it's really hard to understand the area of something and the ability. So you typically want to steer away from a pie chart. Sometimes you might have a boss that says, put this in a pie chart. You do what your boss says. But just wanted to show very, very quickly, I don't want to do that. Typically, a better idea would be to understand something like a tree map from a perspective of like your brain's ability to understand area. Using a square like this, I can quickly look at this and see how much larger group A is compared to B, C, and D, right? And using something like a tree map is a great way to represent a proportion of a data. So if we, same sort of thing you'd want to do with a pie chart, a tree map is a great, great tool to help you understand that from a little bit more, because the human brain can actually understand this more efficiently than it can using a sort of sphere or a circle. So again, we want to make sure we don't mislead our audience, stay away from making the reader estimate volumes. So that same sort of how we pulled out that one piece, sort of stay away from that because it doesn't help your brain understand the area and sort of the size of that specific piece, and stay away from shapes that are hard to estimate values. So yes, unfortunately, that does mean pie charts. Any questions on sort of what we talked about? We just got 14 minutes. We're going to go through some code that I've already written. I just want to sort of walk through now answering some questions and how we can use explanatory visualizations for that. But any questions on anything that we've talked through so far? You guys did great. Thanks for being a good audience, and thanks for chiming in. I love to hear all of your opinions. You guys are all brilliant. Any questions? Okay. Reconnect. Okay, so here's what we're going to do. We are just going to look at some data. I'll make sure I put this in the chat for you guys. Let me make sure that my sharing is good to go. You should be good. Yep. Okay. So what we're doing is we're dealing with this life expectancy data. And so what we want to do is it's a data set, shows various statistics for hundreds of countries for 15 years. Each row is one country during 1 year. And this data set is available on Kaggle. Now, if you just make a copy of this, the data is a URL, so you can just make a copy and you don't have to download it. But okay, we have a couple questions that we're going to build out and visualize. And if there's anything that you guys want or any other ways you think we can do that, at the end, we'll go through and see if is there any different ways we could do that. We only have 13 minutes, but really just wanted to show you the difference with explanatory data. Okay, so I'm going to import this, got it, creating my DF. Perfect. I see here are my certain columns, my country, my year, my status, life expectancy, all their data types. Great job. You guys crushed that. You know that. And then if I'm looking at status, there is two different values where developing and developed, right? So I'm looking at that. I'm sort of, and this all comes from also just understanding my data, which we said is a really big piece to know. You have to know your data. When I'm dealing with these questions, I might want to understand, well, how does a developing country, right, or a country in the status of developing compare to that of developed, right? And so that's just by knowing my data, going in and understanding what's going on. I can use these tools to maybe create a hue or to do specific things. So our first question is, does education increase life expectancy? So I've got two different versions here. Here I'm using Seaborn because Seaborn out of the box is pretty easy. And what this will do is this will create a scatter plot where I've got my data I pass in as my data frame, which we just created up there, where I am wanting to see, does education increase life expectancy? And here I'm doing education as my X and then life expectancy as my Y. And usually when we're dealing with a question like this of, what are we using to see if there is an effect that is going to be our X. So in this case is schooling causing an effect on my life expectancy. And here we can see that there is a pretty positive correlation, right? To where it seems as if the more schooling, the higher the life expectancy. But we also talked about that sometimes when you have a lot of data points, a reg plot would actually be a little bit easier for you to understand because it creates, remember that line and says, okay, yes, no, there is a positive correlation. It does create that line for us. The things we did to change that is, remember, we added in our line keywords and then my scatter keywords to change the size and then to create a color of black, and then the style or LS, where I've got this colon. I could have done it as a dash, run it, and now it creates my dash here, right? I could have done either one. So this is a great example of explaining or having this solid question. And if, your board were saying, is there, we have this fund and we have this money and we want to, raise the life expectancy of developing countries. What are some tools? What are some things we can do? This would be a great chart, right? To show, hey, there is a positive correlation. It seems like when schooling increases, absolutely, so does life expectancy. And so one thing to note is on your belt exam, some of you guys lost points for not explaining what's going on. Now, maybe that was because maybe you didn't quite understand the visualization you created and what was going on. Sometimes that happens. But we want to make sure that we are able to explain what's going on and get in the habit of what's, explaining your code and explaining what's going on. So here, there seems to be a trend that as schooling increases, life expectancy increases. I did also put this on here are 3 questions to answer if you did want to go through them. And then there is different charts as well. I'll share both with you. So there's a little bit more intense charts. If we wanted to do that, I'll share both with you. Like this guy right here, which does the same thing. We just used a different version of R. Instead of using Seaborn, we did Matplotlib. Cool. So the next one is, does the development status of a country affect schooling or life expectancy? And so this one, again, by knowing my data and understanding that it's a binary category, right, of developing or developed, it's either one of those, right? There is that category that we can use. Remembering that Seaborn has this great parameter we can pass in called hue, right? I can pass in this argument and give it a column because I said data df. I can give it a column in which I want it to create a hue. Now it isn't, hue doesn't just work on binary columns, but the more you get, the more confusing it can kind of be and doesn't really help or anything of that nature. But here it's great for helping. Does development status of a country affect schooling or life expectancy? And here I've got my schooling and we've got my life expectancy, and I can quickly see with my hue that yes, if a country is classified as developed, schooling is increased, right? And so typically you can see a huge culmination of my developed on this higher schooling route versus this smaller. And secondly, where my life expectancy is, yes, I can see that the sort of general consensus is yes, right? This does really affect the status as well. Cool. Now there's another way you can do this. The scatter plot would have told you that. There's another way you can do this where I can say, I can create 2 charts on the same axis, right? And so if you guys don't recall, we talked about this in our office hour last week. I think it was our second office hour of last week, wherever there's a recording, where we talked about understanding what a fig and ax was and how we can create subplots, meaning that we can create multiple plots onto what we call our axis, right? And I can create different rows and I can have multiple within sort of the same figure. And so here, if I create a bar plot where I pass in my data, I've got my status and life expectancy. And remember, I can target because I've got 2 rows. I got 0 and 1 because we start at 0 and go to 1. I can target each specifically, right? Where I say on axis 0, this is where I want my bar plot and I want to create my title. I can also create another one on 0. Yeah. And then on axis 1. So on the next row, I can do this one with the schooling. And here I can fit this to where it says, okay, schooling versus status. I can see, yes, developed does have a higher impact, right, on schooling, right? So if they are developed, on average, it's 16, and on average, it's somewhere around 77, 80 versus developing. We can see on both. This is a great descriptor that, yes, the country status does affect life expectancy, and it does affect schooling. So developing countries have a lower life expectancy and lower schooling than developed countries would be a great way to sort of walk through that. Cool. Great. So there's a lot of chatter. Yes, something to point out, blue and orange is a very, very common one. You know, if you were to see like red and green, there's actually a really common color blindness that cannot detect between red and green. And so utilizing the, things like blue and orange is much, much easier for people who are colorblind, that they can really distinguish this between some people. You know, I teach I taught an AI fundamentals course for cloud computing with Azure. And sometimes people were on there and like, I don't see the difference. It was weird, kind of awkward, because I'd be like, actually, that means you're colorblind, because Microsoft themselves had a example of a map that was poorly colored. And so they didn't understand the difference. So, okay. So any questions on what we've done? Any questions on this guy? You guys have access to all this code. And so if you guys did have questions, obviously you can look at the documentation. Okay, we'll go through the last one. We got about 4 minutes left. We just gotta go through the last one. Okay. How have schooling and life expectancy changed over time? So if I'm dealing with this, I want to see, remember that looking at our data, it has it per year. And so each country per year. And so what I want to do is I want to group by year. And then here I'm using the mean. So I'm taking everything, I'm grouping it by the year, and I have this mean. What I wanted to see is schooling and life expectancy over time. And so by creating that, I have my group by, I have my individual years, and then I have my life expectancy. And what this allows me to do is create something to see the trend of if life expectancy increases or decreases. Same thing with schooling per year. Is there any sort of graph that you guys can think about that will help with that? I haven't necessarily taught you yet, but the evolution of data changes over time. Yeah, exactly. Something like a line. A line is going to be really, really helpful, right? And so here, all we did was we created this line DF, which is I just took this value and created a DF because I want to see certain things, right? Life expectancy. I think I also did GDP, life expectancy, schooling, and then I was just curious, so I did GDP. So what I can do is it's another way to do multiple instead of having to create my figure and my axis and target them. What you can do is you can say line df dot plot. Now this is a pandas line graph, right? Where I am saying my Y is, and I pass in a couple different columns where I have life expectancy, I've got schooling, and then again, I have GDP. Now, when I say the subplots equals true, that's what allows the multiple graphs. My marker is what gives me my dots. And then my fig size is obviously the size of my actual figure. And so by just running this code, this is what it gives me. It gives me these three graphs, and I can see life expectancy over the certain years, right? This isn't the most optimal, right? Because if we think about it, what are some issues here? What are some issues that, you know, for this, using these three here?
The legends are not on the same side.
Yeah, the legends aren't on the same side. What's another issue? Like, how could this be fixed?
Is this supposed to compare? Like, I'm looking at this and thinking it's really hard to compare between the three because you have to constantly be comparing them by scrolling down. Is that
So yeah, the question is just how have schooling and life expectancy changed over time? So it's not necessarily comparing.
Okay.
We just want to see how has life expectancy changed and how has schooling changed? And I threw in GDP just for fun. Jessica, yes, all on same graph. What else is another issue here? I see a couple issues.
the x-axis only, the labels are showing up at the very, very bottom, but it's
Exactly, right? This is only showing up at the very, very bottom. So if I wanted to know life expectancy here, I now have to scroll down to, oh, that's 2004, right? And so, and also not explaining, there's no label on my y-axis. So even though this is nice because it's only one line of code, getting used to and being able to do something like this, where I really have autonomy and full control over my graphs, would really helps us and helps prevent us from creating something like this. I believe there's a better example on this guy. Yeah, here, this is much, much easier, right? Again, doing my fig and axis, creating subplots where I've got 3 rows, 1 column. And here, this is much more understandable. I've got an axis here, I've got a title on my Y and on my X. Each one has the different year, average age of death. We see this sort of decrease, then increase again. So that's an interesting one. Schooling index, we can see that increasing, our GDP in millions increasing. Let's see what our average year of death, life expectancy, average year of death. 70 decreased. So it looks like even just our average national life expectancy decreased for a little bit and then is now getting larger. It's a little bit interesting. But you can see just even in the difference, right? And me being able to read this is much, much easier to read by having this full autonomy here. So any questions? It's exactly 6 o'clock. Any questions on what we've talked about? Yeah, David's got a great point that this is pretty, like it looks pretty drastic, but when we look, this is a year and a half, right? Just a quick drop off in 2002. So I'd be really curious of what happened there.
What is it missing?
You what?
Maybe a 2-year drop isn't a big deal, but maybe it is, because when you see, oh, okay, it dropped by 2 years. Wow, that looks like it dropped off a cliff all of a sudden. And you go, so that's where you can, data could be, or your graphic could be manipulated, to show something it's not, or it could be like, well, it's just a blip, it's just a rounding error or whatever.
Yeah.
Deviation from the mean. So whatever.
And now even looking at these, I'm not sure, because if I look at this guy, same data, this just increases from 2000, starts at 67. This guy, oops, starts at 71. I'm not sure what the difference here is, because you're both grouped by mean. Interesting. I'll have to look at that. But
if you put a scale starting at say age 50 to 70, it would look drastically different. The line would just go, oh, okay, it's kind of straight across. Well, I guess it just depends on what are you trying to communicate, to your audience and how you want to represent that.
Absolutely. Absolutely. Any other questions? Well, that's all I have for you guys today. Like I said, today's a little bit easier. Sorry for my poor English. Much easier. I know that you guys have had a crazy week and weekend. So I hope that you guys had fun sort of understanding explanatory. We're going to look more in depth on Thursday at this and how we can, alter and change different graphs. And I will make sure also, just as a heads up, almost all of you guys, I have 8 left for grading assignments. So almost all of your assignments will be done. I'll make sure I get them all done tonight. So if there are resubmits, you have ample time to get that done. If there is any questions, I will stick around. Other than that, I hope you guys have a wonderful night.